Hi everybody. These are the videos that go with homework 10.5 for MathXL. So see notes to fill in. So I picked out some of these off of the MathXL model and the rest follow just like it. So here we are finding area of a kite and a rhombus. And both of them I put together because they use the same formula. So you're going to want to write down somewhere area is equal to 1/2 times diagonal 1 times diagonal 2. And on a kite, so let me remind you what the kite looks like. You can remember what it looks like from a typical kite from the sky, but a kite is unique because it has two adjacent sides that are the same. And then the diagonals right here would be this straight line from here to here and the straight line from here to here. And it's unique because they form 90-degree angles, so you could use properties of right triangles in there. So the diagonals in this case would be that line and that line. So where it says diagonal 1 times diagonal 2, you want the length of each of those. A rhombus is also the same formula, and let me remind you that a rhombus has all equal sides. It's a parallelogram that has equal sides everywhere. And what else is unique about a rhombus is its diagonals, so there's one, and here's the other one, and its diagonals also form a 90-degree angle there. So we will use properties of right triangles, such as SOHCAHTOA to figure out sides, and a squared plus b squared equals c squared, the Pythagorean theorem. All right, so let's give it a try. There's our formula, 1/2 diagonal 1 times diagonal 2. Find the area of the kite. So sorry it's a little blurry, but this is the best I could do. So diagonal 1 and diagonal 2, doesn't matter which one you call diagonal 1 and diagonal 2, but the diagonal goes from here to here. So that means I want the length. It says this little piece is 3, this piece is 7. So 3 plus 7 for the orange one is equal to 10. You have to add it and get an entire length. And then I'm also going to find the length of the diagonal from here to here. And that diagonal is 6 plus 6. Each piece is 6 and 6, which gives us 12. So now I have all the information I need to get the area. Area is equal to 1/2 times diagonal 1 times diagonal 2. So area equals 1/2 times, one of the diagonals is 12 and the other diagonal is 10. Doesn't matter if you flip-flop those. All right, that's easy enough. You can do in your head, or you can type it on Desmos if you need to. What's half of 12 is 6, and 6 times 10 is 60. So the answer here is 60 square meters for number 1. All right, this one, that's a kite. Here's an example. The next 3 I'm going to give you are examples of a rhombus. So here's a rhombus. That means all sides are equal. So if I look at my picture here, these 4 sides are equal and they form a 90-degree angle on the inside. So this picture right here says this piece is 19 and it says from here to here is 24. Okay, the reason that's helpful is because your diagonal goes from here to here. And something else you should remember about parallelograms is that the diagonals are bisected. So if this piece is 19, then this side is also 19. So to get the entire orange line, I'm going to do 19 plus 19, which gives us 38. There we go. Now it's in the picture. And then I also need to get the diagonal that goes from here to here. And likewise, if this is 24, then this piece is also 24. So 24 plus 24 gives us 48. Oops, 48. And now I have both of my diagonals. So I'm going to use my formula. A equals 1/2 times diagonal 1 times diagonal 2. So 1/2 times 38 times 48. And that answer ends up giving us 912. And so on MathXL, it says the area of the rhombus is, so you'd put 912, and then you got these choices, and this is area. Area is measured in square feet, so you'd want to put, or I should say square units, and in this case it's feet. All right, so there's that one. I'm going to do two more, and these get more difficult as we go. So number 4 says find the area of this rhombus. I can see from here to here is 10. So if that side's 10, then this is also 10. So my first diagonal is pretty easy. 10 plus 10. I'm just going to put that one in orange. 10 plus 10 gives us 20. So the orange one right here would be 20. Now the problem is we don't have a length for this side. So that's where you're going to have to put an X, and you can, if you look back up, I reminded you that these hit at 90-degree angles here. So I see a right triangle right here, and the right triangle has X for this side, 10 for that side, and 26 for the hypotenuse. And I want this leg right here. So since I know sides, I'm going to use that formula over to the side. A squared plus b squared is equal to c squared, or leg squared plus leg squared equals hypotenuse. And your c is always opposite the 90. So find the 90 and draw out. This is your hypotenuse, or your c, whichever one you want to call it. So it's going to go like this. Leg squared plus leg squared. So x squared plus 10 squared is equal to 26 squared. Okay, if you're doing this by hand, then this would be x squared. 10 squared makes 100. You can type that in on Desmos or your calculator. 26 squared is 676. Then you would minus the 100 over. So x squared is equal to 576. And then take the square root of each piece, so x is 24. So feel free to pause the video if I went too fast. So now I know that this piece is 24 right here. That's that side right there, and if that's 24, then this piece is also 24. So now I can get an entire diagonal right there. 24 plus 24. And that gives us 48. So now I have both of my diagonals. So area equals 1/2 times one diagonal, the orange one, times the other diagonal. And half of 20 is 10. 10 times 48 is 480. So your answer would be 480 square inches. All right, number 6 is the next one I'm going to model, and we got to do some trig on that one. So I'm going to make a new video for it.